it.
Hi, everybody. This is Erica from National Hemp Association. Thank you for joining us for our next installment of our In Conversation With series. Today, we are honored to have Michael Woods from Black Buffalo 3D. And welcome, Michael. Thank you for being here.
Thanks, Erica. It's a pleasure always.
Yeah, you're one of those guys that I have met on this journey that I feel extraordinarily blessed to have met. This journey has been very interesting so far, and for whatever reason, you're just one of those people that I feel like I've known forever, even though it really hasn't been all that long. But super interested in everything that you've got going on. So if you don't mind, if you could just start with a little bit of a background on yourself.
Yeah, okay. On myself, I'm a finance and tech person. My background has always been in the financial services area in terms of asset management and banking. My most recent roles before I became an entrepreneur was building out the business for Deutsche Bank Asset Management in the Americas. And then after that, being the CEO and COO for the Rothschild family out of Europe for all of their businesses on the asset management side here, and doing a lot of cross-border with Asia that include public, private equity, debt, alternative investments, private equity, private debt, a lot of tech buying and selling, etc. So from there, I just became an entrepreneur, and I got a call from the Hyundai family about 3 years ago now to build out a global accelerator for our parent called HN Inc. To take all their products, services, technologies, bring them to America, commercialize their pilot or prototypes, then mass produce it, and then distribute it through the world. And Black Buffalo is one of those companies, and Black Buffalo is a 3D construction printing company. We build the technology that then builders and developers and governments will take our equipment or our large gantry robot that prints walls and structures for homes, commercial, industrial applications up to 4 stories high. We're one of the fastest, and we are the tallest printer out there in the world. And the big part, Erica, that we do is the manufacturing and the material science around the concrete that's used in our devices. And we're really trying to get to where we can use hemp within the hemp load-bearing concrete, which, there's really not a industrialized or standardized and coated hemp load-bearing concrete out there anywhere in the globe right now, and we'd like to be the first ones that create it.
I have no doubt that you will be. But even traditional hempcrete is, still going through its paces in getting the kind of standardization and codes in place that will enable it to be a widespread, widely used product. So the idea of having it be load bearing and also being able to be done as quickly as a structure can be done 3D printing is just mind blowing. I've seen some of the videos that you've put out that show it in action, and it really is just mind blowing. How long has this technology been available?
So this our technology is about 7 years old now. It was an acquisition from our parent, HN. The technology originated in Korea. Then we commercialized it here in America. The technology for the material, though, that we've just created is about 2 years old. We're the first and only in the country, or actually in the world, that has created, unfortunately, a Portland-based with polypropylene fiber material that is coded and standardized for 3D machines, not just ours, but anybody's machines in the world. The biggest regulator for building codes is ICC, the International Coding Council, and the code that we just passed is AC 509, which regulates the machine process, the structural component of how to build the wall, and then the output, right? The wall itself, the compression, the fire, the slump, the seismic, etc. And that's where we have to get to with a hemp concrete. Is it now that we're the first ones and the only ones to pass that AC 509, which you're all going to see this within the next month. huge announcements coming out, right? So now that we've got that done, and it took a long time, it took a good 2 years to get that completed, and a lot of money. Now we need, right? Now we need to transition that traditional mixture of using what everybody's used to, but still, of course, excreting way too much carbon into the environment. Now, how do we get to something that's much closer to a net zero component that's load bearing? That's what we're working on.
So is it in replacing that polypropylene product that hemp has the opportunity, or are there other components that are candidates for being incorporated?
Yeah, it's mostly that. You're spot on. It's replacing the polypropylene fibers. Our fibers now, it's plastic, right? So it is recycled plastic that we're using. And the biggest emitter, though, inside any concrete is the Portland cement piece of it. So the more and more that we can decrease the percentage of Portland in the overall mixture, and also decrease a lot of the what's called super plasticizer, right, which are mixtures that help the concrete to be not slump as much, not shrink as much, etc. And then fly ash, adding that to it, of course, is a very good natural component into the mixture as well. Though all those things help, but the biggest part of the curing process and the compressive strength, a big help are those fibers. Right. So that's why hemp is so important to us because of the strength of hemp. The hemp fibers, some of the strongest agricultural fibers in the world. So we want to really focus on hemp to be the first fiber that we use in a load bearing concrete. There'll be others, but we want hemp to be first.
So as opposed to a traditional concrete, hempcrete, that is a mixture of lime and hurd, you'd be using the bast fiber to sort of create that extra strength. And does that reduce the weight of the concrete as well?
Yeah, because the more, and you hit it on the head there, the lime, right? Lime is less weight than Portland is when you cure, right? Just go back to ancient times. Concrete was created by the ancient Greeks and Romans. They used 3 main ingredients, right? They used lime, they used seawater, they used volcanic ash. Then they ended up putting Portland clay into it as well to give it more structure, right? And those things are still standing. It's crazy, right? So that's what we're kind of going back to, is going to that lime side. The problem is the compressive strength of what we need in many of these great big buildings that compared to 2 or 3 story buildings back during ancient times, you need a stronger material. So the hurd, those long fibers will actually come down to millimeter sizes for us, but we also need to do experiments on which seed are best for the fiber strength. And so we're going to have to do multiple different scenarios, different mixtures over the next year. It might even take 2 years to really get to the best, let's say, supply chain of the fibers that we should really select for the material.
So you're going for the gusto, like straight out of the box, like going from nothing to a hempcrete mixture for the 3D printing that can do any size story building, and is completely load bearing. Like, it's not going to be incremental. It's going to be like, here it is, guys, like kind of revolutionize it. That's going to be amazing.
Well, we're not really slow movers, we're Americans. We just go, right? So we're going right into it. If we had not already done the ICC tests, right, to understand how hard they are, and also how many tests there are, and how many samples you have to make, and how long you have to print, and there's all kinds of pieces to this. If we had not done that, then we might have taken it in stages. But now that we really get it, and our I got to tell you, our scientists are amazing, on the material side. So we've sat down, we've talked about it. Look, folks, what do we do here? Do we take an incremental step, and do we leave Portland and just replace the polypropylene fibers, so you have a hemp additive mixture? Or do we just go all the way and finish it up? Our first thoughts were to do that intermediate step. And as we kept going down the flow chart, in the Gantt charts and saying, okay, this will take this long, that'll take this long, we're like, oh, forget the intermediate. Let's just go. Let's just make this, because the intermediate step isn't, we feel anyway, and we could be totally wrong, we didn't feel like it was going to be a strong enough step to convince people to really go that way, because you still are using Portland and you're losing a lot of that elimination of greenhouse gas emissions.
Right, because I guess if you did that, your only option would be to continue to use the Portland to print foundations, and then use a lesser not material for the structural part. Well, maybe I'm not understanding that part.
Well, it's a good point though, because one of the things that we're trying to convince builders of, remember, builders are our clients. We're not the builder, we're the technology. And when we build walls, we build kind of like the width of a CMU block. You've seen blocks before, right, of concrete? They're 8 inches wide. So we do the same width of building so that nobody has to change their overall architecture structure of walls and homes that they already know. So we have a 2-inch inside wall and a 2-inch outside wall that's load bearing. That's the Portland that we use right now with polypropylene fibers. Now that inside, that 4-inch inside, 2 outside, 2 inside, 4 inside hollow, right? There's your total 8 inches. So that 4-inch inside hollow core, most people fill that for more strength and get rid of mildew and everything else, which non-load bearing hempcrete is perfect for that, because both our outside and our inside wall are load bearing. They're 7,500 PSI, which is 2 times as strong as code. Wow. You don't need any more load, right? Just pour hempcrete in the middle. So that's what we're trying to get people to start with. While we're working on the load bearing side, start getting used to using non-load bearing hemp inside for all the benefits that it gives.
So, okay, just a little bit devil's advocate here. Mm-hmm. So for traditional hempcrete, it's my understanding that it is the exposure to air of the lime that is actually what continues to sequester CO2 throughout the lifetime of hempcrete. Do you lose that in this scenario because it's sandwiched in between two load-bearing concrete kind of walls? Yeah. Or so does it need, so could you, instead of putting traditional hempcrete in there, could you like blow like a dry hemp insulation, or use like the bat hemp insulation in between there, or does that defeat the purpose?
That's a good question. I don't know the answer to that. I'm not an insulation expert because we're not the builder, right? But I think you're right. When you put the hempcrete in the middle, I think and remember, everything's got to be waterproofed as well on the outside walls. So I don't think you're going to have too much porousness. You're going to have some, but I don't think you're going to have enough to really do what you're saying. And of course, there's a lot of folks that are still questioning whether or not the dead plant sequesters. We're on your side, where the mix, the chemical mix between the lime and the dead hemp fibers, creates some continual sequestration. We're with you on that, and we're trying to also get different universities, Virginia Tech, Penn State, to really help us with their papers to prove that out. And they're working on that. And once that happens, fantastic. Nobody can question us anymore.
Right. I from the research I've said, it does seem to indicate to me that it is the lime that does the obviously the cultivation of the hemp, if done in a regenerative way, is a great sequesterer of carbon in its own right.
Right.
But use as a green material, that's all pretty fascinating. So are the 3D printed sections, are they waterproof, or does it need to, could that be one of the benefits of putting the hempcrete inside, that it provides that moisture barrier and still like, because one of the things that makes hempcrete so desirable as a construction material is it is breathability, and it regulates moisture like in that very kind of natural way. So would that potentially be an added benefit to the 3D construction in addition to the insulative qualities?
Huge benefit, right? Because inside the middle, right, you're always going to get moisture, right? Because you're going to have gaps in the wall. You're going to have tubes coming in, right? Maybe you got a fireplace, and you got a fireplace coming out that attaches to the wall. You've got the roof that ties in, right? And maybe sometimes that roof's going to have a crack and you're going to drip into the middle of the wall, right? So that moisture barrier is huge in between. But to your first question, yes, you still have to have waterproofing on the outside of the wall.
But that would be sort of like in current construction, the kind of like Tyvek kind of outer coating that you put on before you put your siding or whatever on.
Right.
And then how are the inside walls finished?
The inside walls usually have two different things. You have either you keep it exposed, kind of like an exposed brick wall, right? Which is usually kind of cool. You got the 3D look inside, but they might sheen it or paint it or stucco it, right, on the inside, or they'll put a drywall up, right? They'll rough it out with a 2x4, really, really thin. And the areas usually where you see the 2x4s and the drywall is where you put your plumbing, right? The plumbing usually goes on that side of the wall, especially where you have the potential for freeze, right? Maybe not in Florida. You can put your tubes and your electric wires, et cetera, through PVC inside that 4-inch core and then fill it afterwards. But a lot of people where it might freeze don't really like to put that inside a concrete wall, because if it freezes, you kind of got to get to it and you got to cut.
But I bet if you put hempcrete in there, it wouldn't freeze. That would be interesting to find out.
More than likely, it wouldn't freeze. Yeah, the R factor would be somewhere between an R35 and 40. So it'd be really hard for that thing to freeze. But you also have to get inspectors to agree to that.
True.
Yeah.
And I imagine by the nature of it being, the walls being concrete by nature, that provides a pretty good level of fire retardant in its own way.
Oh, absolutely. It doesn't burn, right? It can crack from intense heat. All concrete, no matter how strong it is, right? Intense heat will crack it and it'll crumble. But in terms of burning like wood or stick, no, no concrete does that.
And you're eliminating a lot of all of the wood framing that a traditional home would have, right? So your fire risk goes down, and then you add hempcrete on top of that, and then you really have something that I think would be extraordinarily beneficial, particularly when you look at places like California that suffer such devastating fires.
Well, in California, starting in 2025, the new building code does not allow wood to be used at all. It's only going to be concrete.
Oh, wow. I wasn't aware of that.
Yeah.
Which makes sense.
Yeah. Same as Florida, same as, Mexico, Central South America. There's no wood used down there. Africa, they don't use wood. They use CMU block. There's no basements. They just do slab on grade, right? And, this really is the future of that, because those blocks, it's all block work, right? Those blocks are really heavy, takes a ton of labor, takes a ton of time. It's hard to get it there to the site because that's a lot of weight to transfer, right? Now you're just bringing the bags, right, of concrete, making the concrete right on site and 3D printing it, right, in no time, right? We can 3D print 1,000 square foot home frame of the home, about 10-foot high walls all the way around. You leave gaps for windows, doors, outlets. It's all programmed in to the 3D program called Rhino. You can print that in 22 hours. 1,000 square feet home frame in 22 hours. That's equivalent to almost a foot a second.
Wow.
It's about 10 inches a second.
That's amazing. And so the biggest hurdle is just getting the printer to the site?
Yeah, well, it's demand versus supply. So we're one of the largest suppliers in the world now. of printing machines, and we can still only build 5 per month. So think about that. That, you know, one company might want all 5 of them for one of their big projects. So us and all of our very nice, you know, competitors, frenemies, what do you call them, right? We think of all of our industry folks as friends because Cooperation. There you go. That's perfect. Because, you know, this is a growing industry. It's a new tech that's out there. So there's no reason for anybody to be, you know, selfish on this. There's so much business out there for everybody. It could be 100 Black Buffaloes, for goodness sakes, and we'll not be able to keep up. So, you know, all of us are facing the same thing. There's so much demand for people to print rather than do stick and block. We just cannot supply enough product. We can't get it out quick enough.
Well, that's a happy problem to have. I guess.
Yeah, it's a good problem.
That's a good one.
Yeah.
But it has striking parallels to the hemp industry.
Yeah.
So like you have some infrastructure challenges in order to be able to produce the printers at a scale to meet the demand.
Right.
So as it pertains to hemp, in looking at the potential to using either a traditional hempcrete mix in the interior of the walls, versus having a complete load-bearing mixture at some point, are you concerned about the state of supply chains of hemp as it sits now? And do you have an idea of what kind of specs and volume that you would potentially be looking at? So maybe on the hemp side of things, like people can start trying to prepare to meet that demand when it comes.
Yeah. Great question. We don't know yet because we're still experimenting with how much hemp fiber needs to go into our concrete versus the polypropylene. So polypropylene is a 0.1%, just an example. Maybe it's 0.5% for hemp fibers. We don't know yet. Once we get to the right ratio of that hemp replacement, then that'll give us a good indication based on the amount of products being used by our clients now with the traditional material. It'll give us a good indication of how much we're going to need and where to get it from. Because everything for concrete also has to be delivered locally, right? Because it's heavy, right? It's really heavy stuff. Hemp fibers are not that heavy, which is good. So there, maybe that can be shipped a little bit more than all the powders. But the powders, if we're building something in Mexico City, we're working with the local concrete company there that's creating the mixture there, right? We're working here in the United States and Canada, then we're working with a concrete company called MAPE, right? If MAPE doesn't have that same factory capacity in Mexico City or Guatemala or Chile or wherever, then we're going to use local folks, and that's our agreement. MAPE's like, look, you got to use someone locally because we can't ship it from San Diego, right, all the way down to Baja. If you got a job down there, that's going to double the cost of the concrete by the time it gets there, right? So we're all on the same page that we're trying to do everything as cost effective as possible for the contractor, the developer, the government that's building the project. So we'll know more about the supply chain, but remember, it won't be us. It'll be the concrete companies that we will license the hemp concrete that we own. We'll own the IP, then we license it out to suppliers, then the suppliers distribute it.
Makes sense. So in essence, in this scenario, the things that are going to reduce costs are also going to add to the environmental benefit as well.
That's right. That's absolutely right. Right, because you're not trucking it.
Right. So anytime you can eliminate that, you're doing good all around.
Yeah.
Have you done any experimentation with putting hempcrete inside the hollow places? I'm curious as to how it would affect the cure time of the hempcrete itself, and does that slow down the overall project because you have to let the hempcrete cure, or can you have just some access holes to let air cure the hempcrete before you close up and put that moisture barrier in? Or how do you think that'll work?
I don't really think there's going to be any difference between the curing process of hempcrete versus regular crete. because you can't close that wall that you make or that product that it could be a precast product that you're putting in the ground after, for water movement, etc. All of that's going to have to cure anywhere between, for us, we usually cure in 3 to 5 days, depending on temperature. And when you're done printing the wall, you don't really pour in the middle yet until you get everything in there, because the plumbers and the folks that are wiring, the electricians, et cetera, they're going to come in and do all their work. Then it has to be inspected, right? So you can't really close it all up until it's inspected. So all of that center, remember, isn't load bearing. It doesn't matter, right? It's all, your load bearing is already there. So it's just going to be a choice. Do you want to do it for moisture, for more insulation, whatever it may be, or do you want to leave it open?
Right.
Do that too. So we haven't started to put that in our experiments. We've just been experimenting with the load bearing, and we're waiting on a standardized mixture that somebody like MAPE or somebody, very large that we work with in terms of concrete providers can replicate and mass produce, right? Because if we tell people now, go ahead and put in your hempcrete, they can do that, but we're going to find it in mass, right? So we don't want to give the wrong impression until that supply chain's there. And as you know, the National Hemp Builders Association has already been working with ICC, same regulator, right? Yep. Biggest in the world. They've been working with ICC on a non-bearing hemp for residential purposes. And we're hopeful that's very close now. They've gone through the first stage. They're now getting to the second stage. So we're really hopeful that that gets completed here pretty soon. We will endorse that until the sun goes down, right? So we're really excited for that to get done.
So that could end up being a product that you could recommend because there'll be standards surrounding it. And because
absolutely right.
That's another reason. Yeah, big shout out to the U.S. Hemp Builders Association for getting this as close as it is. It's my understanding it could pass as soon as this fall.
Well, we hope. Yeah, we were lightly involved with them back in November, December, January, right before they filed everything. And we were very supportive in our knowledge of, the ICC and what we've been doing with the AC 509 test, which is totally different, more encompassing because it's residential, commercial, and industrial. The NAHB is that's the residential side only that they're working on. But we're really psyched for them to to get that completed this year. That would be great.
Yeah, that's awesome. And thank you for the support you provided in helping get it this far. Like, it's extraordinarily helpful.
It was light. They were pretty far along. It was really light help.
But help nonetheless, which is appreciated. So how did you first hear about hemp and start to think of this as a possibility of incorporating into Black Buffalo?
You guys, from you and Jeff and Wilson, getting to know Jeff, who of course now is a friend, business partner and personal friend, just such a great guy. And, he's the one that said, hey, have you started to look at this stuff? We had already started to think about lower carbon emission materials. And of course, we were thinking about agricultural products in general, but not directly towards hemp. So you all are the ones that educated us and our team to really focus on, hemp as the major substitute to the polypropylene fibers. And we couldn't be happier about it. It's a great decision, and you guided us very properly. So thank you.
Well, thank you. It's pretty, yeah, it's an interesting journey. Like I said, you meet all kinds of fascinating people, and I learn stuff every day. And I've learned a ton from you, both like on the construction side and on the financial side. So speaking of that, you are with Jeff, a co-founder of Replant Hemp. So you want to talk a little bit about that and how that was born?
Sure. So another exciting, piece to helping the hemp industry. So Replant Hemp is a brand new VC fund focused exclusively on, the supply chain and companies that are using hemp in their products. It's the first and only one of its kind to really have everything that they raise for the VC fund, all the capital they raise, be dedicated towards the benefit of expanding the use, knowledge, and supply of hemp, right? Or industrial hemp. Let's be clear of that. So we just opened it about a month and a half ago. We're working towards our first close of somewhere between 5 and 10 million. We want to raise 500 million in multiple funds. This is fund number one, but we want to raise over the next 3 to 5 years. We would love to raise $500 million and invest this all within hemp environment, hemp ecosystem, from the field all the way to the product at the back end. And we couldn't be more excited about a lot of attention, a lot of activity, and the industry needs it. Right? It needs this fund. It needs other funds as well. So we're really hopeful that, yes, we do a good job of this fund in terms of raising capital, deploying it into the right areas that need the most help early. And then, of course, over time, continue to do the same thing. But we're hopeful that this is a catalyst for other hedge fund managers and VC funds to maybe start their own fund or to incorporate our fund as a percentage of their ESG side, their sustainability side, into what they're doing on a daily basis.
It's amazing. And yeah, not only does the industry need it as far as the investment of capital into getting some of these really great startup companies the capital they need to get to scale, but I think the hidden kind of piece of this that's super important too is educating the investors about this potential, because I think there's still so much misconception about what hemp is and what it's not and what it can do. And cutting through some of the hype sometimes can be a little bit challenging, but it's people like you and Jeff and Wilson and everybody like taking the time to talk to these people to make them understand that this is a real opportunity, and the long-term sustainability of it is, there's just so much potential there in so many different aspects. I mean, everything from, green construction to making sure that our food supply is secure with superior nutrition and, replacements of plastics, and just, it's oversaid that we're going to use hemp to save the planet, but we're going to use hemp to save the planet.
Absolutely.
We're going to try.
At least save part of it, right?
Yeah, we're going to do our part to save
That's
it.
Right.
Hemp's not going to fix everything, but it can play a part in helping a lot of things. Mm-hmm. And it's just so personally gratifying to see this all actually start to happen. Moving from being kind of like a grassroots activist to, advocating for federal legalization, and then to have it happen, and then working on the regulations. But this is where we have to prove to everybody that everything that we advocated for is real and can happen. Mm-hmm. And it's people like you that are going to prove us right and actually make it happen. So
we'll all do it together.
We'll all do it together. But super appreciative of everything that you have done, everything that you will do. And thank you for spending this time with us today. It's been super rewarding to get to have this conversation with you. Any final thoughts you'd like to share before we go?
No, look, all this takes time, right? And the secret to any new technology or advocacy of an issue is just consistency and tenacity, right? Don't get discouraged along that wonderful trail and that journey that we all are taking together. And realize it's just going to take more time than we ever thought it would. It always does, right? Keep the pace. Sometimes you're going to have ups, sometimes you're going to have downs. As you've seen, there's some months when I'm really active. There's other months that I can't be because other stuff is going on, right? So let's just keep moving everything forward. Let's keep spreading the word, but also let's keep proving it out, right? And that's what we want to do at Black Buffalo, is to prove out that these agricultural products, most especially hemp, do have applications in some of the biggest industries in the world. Construction is the biggest industry in the world, 14% of global GDP. So we need to continue to move this forward. We're going to have hiccups. We're going to have bumps. We're going to break a lot of stuff. It's going to cost us a lot of money. But at the end of the day, it's going to help so many people to get this right.
Yeah, it absolutely will. And I have every faith in you and your scientists at, doing everything the right way. And like when I get myself frustrated sometimes that things don't happen quite as quickly as I'd like, I constantly remind myself that like the joy is in the journey.
That's right.
And the journey has been amazing and continues to be. And meeting wonderful people like you is a big part of why this industry is so rewarding to me. So thank you again. Thank you for spending time with us. I hope you all enjoyed this edition of In Conversation With, and we will see you next time. Thank you so much.
Thank you so much, Erica. Goodbye, everybody. Thank you.
How do I stay?